we've already seen the steps for building a new law. Now here we've got the reaction that you saw in the title slide. Copper is reacting with sulfur to give you CuS, covellite, a mineral. Now in the data here, we've weighed the copper, the sulfur, and the covellite. Is there a pattern in the data? Well, there are several patterns here, but the one that we'll point out now is that the mass of the copper and the sulfur together is equal to the mass of the covellite. So if you add up the masses on the left-hand side of the equation, they're equal to the total mass on the right-hand side. Check that out yourself for all of these other experiments here. So we have 3 experiments there. The data supports the conclusion that chemical reactions do not change the total mass, because the total mass before is the same as the total mass after in every one of these experiments. Now if we do this over and over and over again, and we try it with different reactions, many different reactions, and we come to the same conclusion, the total mass before is the same as the total mass after, we can elevate that conclusion to a law. And the name of the law is the law of conservation of mass. So remember the law of conservation of mass later on in the course. It gives you a simple way for calculating missing masses in an equation. For example, suppose you made 100 grams of covellite from 66.46 grams of copper. And I ask, how many grams of sulfur did you need? Well, that's easy. If you have 100 grams on the right-hand side, you have to have a total of 100 grams on the left-hand side. So what you can do is take the mass of the copper you had and subtract it from 100 grams. 100 grams minus 66.46 grams is 33.54 grams of sulfur you must have had. We'll do a lot of calculations like that later on in the course. We'll spend an entire chapter, in fact, on calculations of that sort.